Today on Capecchi's Corner, we're going to talk about operations with polynomials. Now, polynomials, we're going to start with the term monomial. And what that is, it's a number, variable, or product, meaning we can multiply together a number and one or more variables with a non-negative integer exponent. So the exponent has to be an integer, and it cannot be negative. Now, a polynomial is when we make up a monomial or a sum of monomials. So, for instance, if I have a binomial, it is a monomial with two terms. That's a binomial. If I have a trinomial, it has three terms. So it looks something like that. Now, the degree of a polynomial, that's the degree of the monomial with the greatest power. So we're going to look at some examples. Okay, let's look at letter A. We have x squared minus 5x minus 4. Now that degree, because that exponent, that monomial, the highest exponent there is a 2. So my degree is going to be 2. And we just finished a chapter on quadratics. So that's a quadratic equation. And the graph, again, looks like a parabola. We just finished that complete chapter. What that means is because the degree is 2 is the highest power, that means that we have two solutions or roots. That's really the important thing about that. Okay. Now in letter B, the degree, the highest power there we have is 3, right? We call that cubic. And again, that means we have 3 roots or solutions. Going to the next one, letter C, the degree there is 1. Now we know this is a line, right? You've graphed a lot of lines in Algebra 1 and in Algebra 2 so far. And we know that that touches the x-axis once, right? And the solution is where it touches the x-axis. Okay, the roots are the solutions. In letter D, the degree there is 5. The highest power is 5. So that means, again, we're going to have 5 roots or solutions. Now, when you see the expression that says simplify an expression, I put that in quotes when you read that. What you want to do is you're going to rewrite the expression without parentheses, right? We don't want parentheses and we don't want negative exponents. Okay, so here are a lot of different properties of exponents, which are really important in all different courses of math. Okay, now I'm not going to go over each one because we're going to do an example of each one in a little bit. So if you need to go back and take a look at this later, you know, this is here for you as a reference as you go forward, but I'm just going to do some examples with that. Here is the definition and here are some more examples, but we are going to do some together. Okay, so again, our directions say to simplify. So whenever we are multiplying exponents, remember this is like we have 3 m's, m to the third, and it's like we have 7. 1, 2, 3, 4, 5, 6, 7. And if we were to add those up, we would get m to the 10th. Of course, we don't want to do this every time. So you just need to know that you're going to add the exponents when you multiply. Okay. Now, when we take a power to a power in math, we multiply. X times 4 to the 7th is x to the 28th. And basically what that says is I would take x to the 4th 7 times. Right? And I'm missing a couple here. Now, again, if you were to add up all those 4s, you would get 7. So it would be 7 times 4, which is 28. Okay, looking at number 3, I'm going to take everything to the inside. I'm going to raise that to the power. So this gives me x to the 2 times 4, which is 8, and y to the 3 times 4, which is 12. Now, the zero product property in number 4 means anything we take to the 0 power is equal to 1. So 5 to the 0 is going to be 1. If I have something like x to the 0, that's also going to be 1. All right, so let's take a look at some division properties here. Some properties that we have. So we have y to the 7th over y to the 3rd. So again, let's take a look at what that really would be. I would have 7, 3, 4, 5, 6, 7 all over 3y's. Now, if I were to simplify these, they would simplify because they're the same. They would simplify. They would simplify. So how many would you have left? You would have y to the 4th left. That's your final answer. Now, again, I don't want to write that out every time. So all I'm going to remember is that I'm going to subtract. And wherever the higher exponent is, that's where my final answer is going to be. So 7 minus 3 gives me 4. And again, I have more on the numerator, so that's where my answer is going to be. Letter B is the opposite. I have more on the denominator. So what the answer here is going to be is 1 over y to the 4th. 7 minus 3 gives me 4, and there's more in the bottom. Now, the other way you can look at that is and I think it's easier the way I just told you, but some people look at it this way. This is y to the 3 minus 7, which is y to the negative 4th, which is the same as 1 over y to the 4th. Now, that is true, and that's the property. I just think it's easier to kind of skip all that and just say subtract them. And because of what I did up here, it hopefully makes sense. If you were to pull all those apart, wherever you had most of them, that's where you're going to end up with your final answer, whether it's a numerator or denominator. Okay? Number 6, again, everything inside gets raised to the power. So this gives me m. 2 times 3 gives me 6. And that's what give me 6 also to the 3rd. So that would give me, if I were to simplify that, that is m to the 6th all over 216. Now, number 7, we're starting to look at some negative exponents. I can't have a negative exponent. So what happens is, right now, this is really a numerator, right? So I like to say go to the other side of the dividing line. Go to the other side of the dividing line, and that negative exponent becomes a positive. And then I need a 1 on top. Okay? The same thing holds true to the other side. There's my dividing line. This negative y to the negative 5th goes the other side dividing line and becomes positive. So that answer is just y to the 5th. I don't even need a denominator there. Okay, looking at number 8, I like to divide dividing line and just go from there. So if I first look at my q to the 2nd, I have q to the 2nd over q to the 7th. I have more q's on the bottom. So I'm going to take q, I'm going to make 7 minus 2, and that leaves me with q to the 5th. I'm going to do the same thing with my r's. I have r to the 4th on the top, r to the 3rd on the bottom. So in the end, I have more on the top, and if I subtract them, I get 1. So I have r on the top. Now, the s is a little bit different, so we have to take a look. We have a couple things going on. I have s to the negative 2 and s to the 1st. So this is where we have to decide that s to the negative 2, that can't stay there. That needs to go to the bottom and become positive. This s right here is fine where it is, so I'm just going to rewrite that. Now I have to clean it up. So I have r over q to the 5th. 2 times, remember this is 1, so 2 plus 1 gives me 3. So I have r over q to the 5th and times s to the 3rd. Okay, so there are some basic properties. We're going to go back and use them in some more involved problems. All right, so let's look at number 9. Again, first we have to do order of operations. I need to get rid of my parentheses. So I'm going to take everything inside this fraction. I'm going to raise it to the 3rd. I'm sorry, everything inside the parentheses and raise that to the 3rd power. So it gives me 4 to the 3rd x. 2 times 3 gives me 6. And this is really y to the 1st. So 1 times 3 gives me 3. Times, I'm going to do the same thing for this parenthesis here. So 2 to the 2nd. And then I have x to the 6th and y to the 14th. Okay, so now I'll just clean this up a little bit. 4 to the 3rd is 64. 2 to the 2nd is 4. So if I were to multiply 64 times 4, I get 256. And I have x to the 2nd time, I'm sorry, x to the 6th times x to the 6th gives me x to the 12th. And then y to the 3rd times y to the 14th gives me y to the 17th, which is my final answer. Okay, moving on to number 10. Again, I'm going to take everything inside and raise it to the power. So it's negative 2 to the 3rd. That gives me a to the 12th over b to the 6th. Now, when we have a negative base, we have to be careful. In this case, I'm multiplying it 3 times. So if I were to do that, that's going to give me a negative 8. So I have a negative 8 on the top, a to the 12th. I'll read that a little bit better. a to the 12th over b to the 6th. Okay, moving on, we have a couple different operations here. I'm going to subtract. So what happens is this negative here, I'm going to distribute that. I get negative 2x to the second minus 3x plus 1. That might be a little bit easier. It's almost like you're adding it now in between. Now, you don't have to write that every time, rewrite that line I just wrote, but it might help you in the beginning. So I combine. I have 4x to the second and negative 2x to the second. That gives me positive 2x to the second. Negative 5x, negative 3x gives me negative 8x. And then I have 6 and 1 gives me positive 7. So that's my final answer right there. Now, in number 12, I have a monomial, right? And I have a trinomial. That's 3 terms. So I'm going to have to distribute that to each term inside. So I have 3x times 2x to the second gives me 6x to the third. 3x times 4x, I have my minus there, gives me 12x to the second. And 3x times 6 gives me plus 18x. I can't combine any of those terms, so that's my final answer. Okay, now we did a lot of multiplying binomial times a binomial. This time we're going to do a binomial times a trinomial. Now, there are 2 methods. We could do it the horizontal method or the vertical method. Most teachers want you to practice both, but in the end, they don't usually care which method you use. It's really more of a comfort. So what I'm going to do with the horizontal method means I'm kind of going across, right, left to right. So it's a form of distribution. So I'm going to take n, and I'm going to multiply it through that trinomial. So I have n times n squared plus 4n minus 6. And now I'm going to do the same thing with my 2. So that's going to be plus 2 times n squared plus 4n minus 6. Okay, so now I have to distribute through. So I get n to the third plus 4n squared minus 6n plus 2n squared plus 8n minus 12. I'm going to combine my like terms. So I have n to the third. I'm going to underline that because I know I used it. 4n squared and 2n squared gives me 6n squared. I have negative 6n and positive 8n gives me positive 2n. And my constant at the end is negative 12. So that's my final answer right there. Okay, I'm going to do the same thing, but I'm going to do the vertical method. So the easiest way, it's almost like if you were going to multiply these numbers, right? You would take 7 times 3, then 7 times 1, and 7 times 2, and your next line would be the same thing with the 5s. It's kind of the same idea. So I'm going to put the longer polynomial, the one that has the most terms on up top. So I'll rewrite my trinomial first, and then I have n plus 2. So I'm going to take 2 times negative 6 gives me negative 12. 2 times 4n gives me plus 8n. And then 2 times n squared gives me 2n squared. Okay, now I'm going to do the same thing with the n. I have n times negative 6 is negative 6n. So I'm going to line that up. This is, the advantage of this method because you can line them up nice and easily. N times 4n gives me plus 4n squared. And n times n to the second gives me n to the third. Combine my like terms, and I have n to the third plus 6n squared plus 2n minus 12. Now, do you have the same answer as you do on this previous problem? You do, and you should, because the binomial and the trinomial are the same. We just multiply them by a different method. Okay, great job today with all your operations with polynomials, and you have a great day.